Okay, so in example 5, we've been told a boy is using a light stick to pull a toy box of mass 3.2 kilograms across a rough carpet. The tension in the stick is 18 newtons and the friction force is 7. For part A, we have to find the acceleration of the box and the time it takes for it to accelerate from rest to 2.1 meters per second. Okay, so quite a lot of useful information in this question. So a boy is pulling a toy box of mass 3.2 kilograms. That's very useful. Rough carpet. So rough in mechanics means there's friction between the surface and the object. The tension in the stick is 18 newtons and the friction we just mentioned is 7 newtons. And we have to find the acceleration of the box. So first we're going to do is draw a diagram. Very, very typical way of starting mechanics questions. So here's my box. The boy is using a stick to pull it. So let's say he's pulling it to the right with 18 newtons. And there's a friction force opposing it of 7 newtons. So let's just slow down a bit and think about why this diagram makes sense. Well, here's the box, alright? He's pulling it with a stick, and the force that's actually causing it to move, if you pull something with a stick or a rope, is tension. Tension is a pulling force, alright? And he's pulling it to the right 18 newtons. And if you're dragging along something on a surface that has friction, a rough surface, there is going to be a friction force opposing it of 7 newtons, but it's still going to move, isn't it? Because the 18 newton force taking it to the right is stronger, is greater than the 7 newton force of friction. So it's going to move to the right. And in mechanics, when we have an object in motion, we always put on a double arrow on our diagram in the direction of acceleration. So we don't actually know the acceleration, so we're just going to call that a meters per second to the minus 2. Now we could also put on the weight of this box and the reaction force. However, because we're only considering the direction of motion, which is to the right, we don't have to worry about any vertical forces. Okay, so because it's in motion, I'm going to go ahead and use F equals ma, and I'm going to resolve in the horizontal direction to the right. So I'm going to write R for resolve and then an arrow going to the right. So what that does, what I need to do now is I need to look at all the forces taking it to the right and then subtract any forces in the opposite direction to the left. In other words, I need to find a net force acting on it to the right. So the net force would be given by 18 take away 7. Alright? 18 wants to take it to the right, that's the pulling force in the stick, but 7 is the force of friction opposing it. So the net force is 11, 18 take away 7. And because I'm using F equals ma, and I need to substitute in mass, so the mass is 3.2, not 32, 3.2, if I accidentally said 32 kilograms, I apologise. 3.2 and then multiplied by A. So this is an equation we can solve for A. I do 11 divided by 3.2. I will end up with A, so 11 over 3.2 equals A. So A turns out to be 3.4375. Okay, so I have the acceleration of the box. Okay, so still in part A, we have to find the time it takes for it to accelerate from rest to 2.1 meters per second. So this box is at rest, it's stationary, and then the boy is gonna pull it with a light stick, and it's gonna speed up to 2.1 meters per second. But we want to see how long that takes, all right, for it to get from rest, stationary, to 2.1 meters per second. Now, because we worked out the acceleration, and this acceleration is going to be the same number throughout, this is something called a constant acceleration. Now, when we have constant acceleration, we can use the Suvat equations. Constant acceleration means we can use the Suvat equations. So I'm going to go ahead and write the Suvat equations, or the Suvat list rather, and let's put in what we know. Well, we know what A is, that's 3.4375. We know what the initial velocity is because the box is starting from rest. Rest means 0 meters per second, and we want to know how long it takes to get to 2.1 meters per second. So I know the final velocity v, and I don't know the time. That's what I'm trying to find out. Now, to use the Suvat equation, you need to know 3 variables, 3 unknowns, and you need to be finding a fourth, which is what we do have here. We know u, v, a, and we're trying to find t. So in your formula book, you do have the Suvat equations. So it turns out the Suvat equation we'll need to use for this one is V is equal to U plus A2. So, okay, so we're going to use V equals U plus A2. So let's sub in what we know. So we've got 2.1 is equal to 0. So U is 0 plus A times T. So A is 3.4375T. And let's go ahead and solve this for T. So I've got 2.1 equals 3.4375T. Divide both sides by the acceleration. And if we do that, we'll end up with T is equal to 0.611. 0.61 seconds. Alright, so now that we've got the time of 0.61 seconds, so let's do part B. Okay, so assuming that the friction force remains the same, what tension is required for the box to maintain a constant speed of 2.1 meters per second? Okay, right, so what we're going to do for this is we're just going to update our diagram. Now we don't know it's 80 newtons, the tension force. We just know it's T newtons, okay? They're going to change, the boy's going to change the tension force, all right? However, we need to work out what force of tension is going to make the box maintain this constant speed of 2.1. So we established in part A that after 0.61 seconds, it's now going to be moving at 2.1 meters per second, all right? Now, if we wanted to remain at that speed constantly, so it's not going to change the speed, that would mean the acceleration is 0. A constant speed means 0 acceleration. Okay? So what we're going to do is we're just going to go ahead and use F equals ma on the diagram again for this box. However, so I'm just going to draw it out again. However, acceleration is going to be 0 now. If I wanted to move at that same speed, acceleration is going to be 0. So I'm going to use F equals ma again, and I'm going to be resolving to the right. That's going to give me T minus 7 is equal to the mass of the box, which is 3.2 times the acceleration 0, but that's just going to be 0. So tension equals 7 newtons. So if the boy's pulling the stick with a force of 7 newtons, all right, the box is going to be still moving at a speed of 2.1 meters per second. Okay, let's have a go at part C. Part C, find the magnitude of the force in the stick and state whether it is a tension or a thrust. Okay, right, so let's go ahead and work out the acceleration.